Alright, let us look at a question where we are asked to evaluate the limit of a rational function. Limit as x approaches 3 of x square minus 4x plus 3 divided by x square minus 2x minus 3. Whenever we are calculating limits for rational functions, let us say the function is f of x divided by g of x and the limit of x is approaching some value a. The first thing we do is simply substitute the value a in both the numerator and the denominator. So we get f of a and g of a. And oftentimes what happens is when we substitute this value a into the functions, both numerator and denominator become 0 and this gives us an indeterminate form. So we cannot proceed further. In such cases, in order to evaluate the limit, we need to factorize the numerator and the denominator and eliminate the factor which is dragging both numerator and denominator to 0 and not allowing us to proceed with the limit calculation. The second point we need to note here is since the substitution of a into the functions are making the function 0, by the factor theorem we know that x minus a is a common factor of both numerator and denominator. So while manipulating these two polynomials algebraically, we need to weed out this factor, cancel it, and then try to substitute a again into the functions and see if we are getting a finite value of the limit. Alright, so let's proceed with this calculation. The limit as x approaches 3 of x square minus 4x plus 3 divided by x square minus 2x minus 3. So let us put x is equal to 3, which implies the numerator becomes 3 square minus 4 times 3 plus 3 divided by 3 square minus 2 times 3 minus 3. If you evaluate the numerator, this is 9 plus 3 is 12 minus 12 is 0, and the denominator, this is 9 minus 6 is 3 minus 3 is 0. So we get the indeterminate form of 0 by 0. So we cannot proceed with evaluation of limit this way. So what we realize here is since by putting x is equal to 3, both numerator and denominator have become 0, we can clearly say that x minus 3 is a common factor. So what we do is we try to factorize both numerator and denominator. X square minus 4x plus 3, x square minus 2x minus 3. Now we employ splitting the middle term technique which you would have learnt in lower classes, which becomes limit as x approaches 3. This can be written as the product of x minus 3 into x minus 1. And the denominator can be written as the product of x minus 3 into x plus 1. So now I can cancel x minus 3 in the numerator and the denominator, saying as x can never be 3. Now you need to understand that in the first case, we directly try to substitute x is equal to 3 because the numerator is a polynomial and a polynomial is continuous over all real values. Our hope was we would have obtained a finite value for the numerator and the denominator, or in some cases, the denominator will not be 0, the numerator can be 0, and therefore the limit value is 0, which is perfectly acceptable. But when we are cancelling these two terms, you must note that we can never cancel these terms when we actually put x is equal to 3, because then we are actually cancelling 0 by 0, which is meaningless. So we get away by saying, look, x is approaching 3, which means it's very close to 3, either from the left hand side or from the right hand side, but it's not 3, in which case I can happily cancel this because that is accepted algebraically. So therefore, whenever you cancel the common terms, you need to write x is not equal to whatever value that you're substituting here. Now this whole problem becomes limit as x approaches 3, x minus 1 divided by x plus 1. So now that we have another rational function, let us test by substituting x is equal to 3 here. 3 minus 1 divided by 3 plus 1 gives us 2 over 4, which is 1 by 2, a finite value. Therefore, we report our answer as the limit as x approaches 3 of x square minus 4x plus 3 divided by x square minus 2x minus 3 is equal to 1 over 2. And that is the final answer.